Shrikant, this is almost the end of June. Why are there water cuts in the city?
Because the monsoon is late.
Why is the monsoon late?
El Nino.
El Nino, right? So who is this El Nino? Why is he causing water cuts here? And why can't the Indian Meteorological Department predict this in advance so that we are saved nasty surprises like this?
Okay, all of these are questions I have also had.
Yeah.
But the only El Nino I know is a footballer named Fernando Torres.
Yeah.
But I know El Nino is a weather phenomenon.
Yeah.
What is it?
You know, when a footballer flaps his wings in Brazil, it reduces rainfall in India.
Butterfly, because when a footballer flaps his wings, Real Madrid and Barcelona get...
Right. So this is the butterfly effect, and things happening near South America can change global weather, right?
Yeah.
But before I explain El Nino's effect on the Indian monsoon, I have to explain the basics of monsoon and rain. Okay?
Okay.
So let's look at this map.
Okay.
This here is India, and below it is the Indian Ocean, right?
Yes.
If you take a look at this whole region, there is this large landmass in the north and a large ocean below. Okay?
Yes.
Now, the large landmass heats up in summer, and that causes the air there to go up. Okay? The Indian Ocean, which has a bunch of moisture-laden air right there, that air gets sucked towards the landmass. Okay, so basically air is now getting pushed towards India. Okay, this moisture-laden air hits the mountains in India. On the left side, the Sahyadris, and from the right side, it is hitting the Himalayas and the Tibetan Plateau.
Correct.
Right?
That's what I remember from geography in school.
And so this air rises up, it cools down, and we get rainfall.
Correct.
Okay, all right. This is the first thing.
Yep.
The second thing you need to understand is something called trade winds. Okay. Now you must have heard this in school geography, but the basic idea is that because of the Earth's rotation, there are permanent winds blowing in certain areas of the globe. Okay. So here, if you see, this here in the middle is the equator, and then you see the two tropics. Okay. Now, air is permanently blowing from the tropics towards the equator. Okay. And this happens in both hemispheres. Okay. And for historical reasons, they are called trade winds. Okay. That is not important. Just remember that there are trade winds blowing like this. And because of the Earth's rotation and the Coriolis effect, this is the direction. They're not going straight towards the equator. They are bent, basically going westward.
Yeah, east to west.
Right? Okay. All right. Now I'm just switching the view to a view of the Pacific. Okay, because that part is important.
Okay.
All right. So what is happening is that this air is blowing east to west, and it is dragging water along with it. Okay. Now the water on the surface of the ocean is warm because of the sun, whereas the layers below are cold.
Correct.
What happens as a result is that this warm surface water gets pushed to the west near Australia and Indonesia.
Okay.
Now, but also if the water on the east, which is near South America, if that water at the surface is going away, then the water from below comes up.
Correct.
Okay? So what you end up with is a situation where in the west, you get warm water buildup, and in the east, you get cold water coming from below. Okay. And by the way, the water below, there are nutrients at the lower layers, and nutrient-rich water comes up. As a result, there are lots of fish. Okay.
Right.
So in a normal year, what happens is that warm water is building up towards the west.
The Australia and Indonesia side.
Right. And this is during the southern hemisphere summer. Okay.
Right.
So around December. And there are lots of fish building up and cold water on the east towards South America. Okay.
Right. It is very weird because we've always considered America as the west, and now to suddenly think of America as the east is taking me a little bit of adjustment.
Yeah.
Probably for you as well. But look at the map and you'll understand what he's referring to.
So this is clear, right? The two things we talked about is why during the Indian summer, we get rain because of moisture-laden air coming in from the Indian Ocean, and why during the southern hemisphere summer, warm water is building up on the west of the Pacific Ocean and fish are building up on the east.
Makes sense. Absolute sense. Yes.
In fact, what happens is that the warm water buildup on the west of the Pacific, that keeps accumulating. Every year, the buildup increases a little bit. As a result, there is a temperature gradient, right? On the west, there is more and more warm water and slightly higher temperature. And on the east, there is more and more cold water, so lower temperature.
Correct.
And as a result, the air on the west keeps rising up. And then air from the east rushes in to meet it, right?
Right.
And this is also, there is also the trade winds going on here, right? So the trade winds are pushing and keeping the warm water on the west.
Correct. So air is flowing from cold to warm. It is pushing the water towards the warm. And at the same time, there are trade winds also pushing the water.
Correct. And that is what is keeping the warm water there, right? Otherwise, according to physics, if there is warm water on one side and cold on the other, they should mix.
Correct.
And it should equalize. That doesn't happen because the wind is keeping things that way. Now imagine that for some random reason, completely unrelated reason, the wind dies down a little bit. The wind reduces. Okay. Now what happens is that all the water that was warm water that was collected on this side and is being kept here by the wind, that gets a chance to flow a little to the east.
Yeah.
Okay. So as soon as that happens, notice that the temperature gradient is going to reduce a little bit because some warm water has flowed towards the cold. So the warmth on the west has reduced and the cold on the right has reduced. Okay.
Right.
Now, as a result of this, because the temperature gradient has reduced, the wind blowing reduces.
Right.
Right.
Feedback. Yes.
Right. Now, wind blowing reduces. Because of that, more warm water is able to rush to the east. Because of that, the wind temperature gradient reduces further. Because of that, the wind dies down further. And you get into a cycle.
Yes.
Okay. And this cycle, what happens is that basically more and more warm water rushes and pretty much dissipates out into the ocean and towards the poles and all of that.
Correct.
Right? This is called El Nino.
Oh.
Okay? Because of some random reason, the wind reduced once and that set up a feedback loop, because of which warm water which had built up on the west of the Pacific, which is normal every year and needed for the global rainfall, that rushes to the east and then it dissipates, temperature gradient goes down, winds go down, and the weather pattern all over the world changes.
Yeah, I mean, I want to ask about how exactly that change propagates, but why would the trade winds get weaker in the first place randomly?
Right. So this is where the butterfly effect comes in play, right?
Okay.
Basically, from chaos theory, we know that, minor small perturbations in the initial conditions can lead to very large differences in the final output if there is a feedback loop going on, right?
I mean, we kind of talk about it when we talk about atomic habits and compounding in a sense.
Exactly.
But yeah, the principle remains the same.
Right. So, I mean, also because, if two people start out with slightly different amount of money and compound over 40 years, one will be rich and the other will not be, right?
Yeah.
So similar concept, right?
Fair.
So it doesn't matter what. I mean, the world is complex, physics is complex, the weather is complex. For whatever reason, wind has to just reduce once a little bit and then that feedback loop gets started and you get El Nino, right?
Yeah, so that is the reason why it's called a butterfly flapping its wings in the Pacific Ocean, which is like a very small perturbation.
Yeah.
Causes major havoc in the Indian monsoon.
Right.
Okay.
Correct. And this should also explain why we can't predict it, right?
Yeah.
Because the beginning of it is random. Okay. The only other thing is that for this to work, the temperature gradient has to be set up in the first place, right? So if there is no temperature gradient, you will not get El Nino, right?
Correct.
Which is why you don't get 2 El Ninos 2 years in a row.
Correct.
But once the temperature gradient is set up, whether you will get El Nino or not completely depends on random conditions, which is why it just randomly happens every 2 to 7 years. You never know when.
I mean, the butterfly can decide not to flap its wings.
Correct.
So, yeah, or the footballer can decide not to flap his wings.
Right.
Right. So, okay. Now let's get back to the question of how this propagates.
Yeah.
Because this is happening in the Pacific Ocean. India is separated from that Pacific Ocean by the Indonesia-Australia landmass that you spoke about.
Correct, yeah. So to explain that, let me switch back to the other map.
Okay.
So here, this is the Pacific region that we just talked about. And this part here is the west of the Pacific, where air is building up, warm air, and it is rising up.
Correct.
Okay. Now let us remind ourselves of what's happening in the Indian Ocean. Okay. Indian Ocean, air is going from the ocean towards India, and by the time it reaches the Tibetan Plateau, it is again rising up. Okay. So this red region is where Indian air is rising up, and this blue region is where the Pacific air is rising up. Okay. You can see basically what's happening. You can imagine two columns going up together like this, and they are helping each other. Okay.
Right.
And just to make sure we understand what is happening, this air that is going up near the west of the Pacific is going to push the air above it away.
Correct.
Right? So that air goes back all the way across the Pacific, and it descends down on the east near Peru and Ecuador, near South America. Okay, so you
Right.
get a cycle like this. Same thing is happening in the Indian Ocean, where this air that went up is going to push the air above, and it comes all the way back here, and it descends somewhere in the lower part of the Indian Ocean.
Okay.
Okay, this is what is going on. Now, let's see what happens in an El Nino year.
Which is when the winds have dissipated and the air is no longer forming that column.
Well, that is not accurate. Okay, what is accurate is that in a normal year, the air column rising would have been here, which is where all the warm water is collected. But because the wind died down and El Nino caused water to rush, right? Before the water has dissipated, what happens is that you get warm water here.
In the middle, okay.
In the middle. Okay. As a result, what is happening is that there is warm air rising up here. Okay. And as before, there is this warm air rising here. Okay. And there is a gap in the middle.
Oh.
Okay. Now imagine, right? Earlier, you had two columns of air, both right next to each other, rising together, helping each other. Right?
Correct.
Now they are farther apart with a gap in the middle. There are two columns of air rising like this. What will happen in the middle?
I genuinely don't know.
Okay. Earlier we said two columns next to each other rising like this, so they get pushed out.
Yeah.
Now instead, two columns far away rising like this, gap in the middle. So some of the air gets pushed in the middle and it descends in the middle.
Oh, okay.
Now think of what is happening. Okay. Now this air column is rising. This is above India. This air column is rising, and now there's an air column falling here. What do you think one rising and one falling column do to each other?
Cancel each other out?
They don't completely cancel, but at least this rising slows down.
Fair, fair.
Which is why in an El Nino year, an Indian monsoon weakens, because now the air which is coming in from the Indian Ocean isn't rising as far.
Wow, okay.
Right?
Okay.
Which is why we get a weak monsoon in India when there is an El Nino year.
Right. I think the major confusion or the major frustration for people stems from the understanding, or rather the belief, that South America is so far away, whereas it is only far away because we see the world in a certain kind of map which puts it far away.
Yeah.
The fact is, if you cross over to the other side, they are practically one step away neighbors.
Yeah. Yeah.
Which now makes it clear that anything that happening in South America is just one landmass away from affecting India.
Yes.
Okay.
And no, not just that. It's not that the air is rising over the landmass. It crosses the ocean and starts rising when it reaches the landmass. So it is the same landmass in some sense.
Yeah, it actually is.
Yeah.
So that means in an El Nino year, India will have droughts.
Not so fast. Okay. Everything about the weather is complicated.
Yeah.
Okay. Problem is that this is not the only thing affecting the Indian monsoon. Okay. There is one other important thing I want to mention, which is called the Indian Ocean dipole. Okay.
I've heard of magnetic and electric
Yeah.
dipoles. The Indian
Similar,
Ocean has a
right?
dipole.
So here is the Indian Ocean.
Yes.
Okay. And the same trade winds are pushing air in this direction.
Oh yeah, I forgot about the trade winds. They still exist.
Yeah. So as a result of that, what happens is that warm water collects on this side and cold water collects on this side.
Okay.
This is called the Indian Ocean dipole. So this dipole sets up a temperature gradient. Because of that, extra wind blows. Because of that, more moisture gets pulled up. Because of that, a stronger monsoon comes into India.
Yeah,
Okay?
I've heard this before, just a little while before. Whatever is happening in the Pacific Ocean seems to also be happening in the Indian Ocean.
Very well said. Because whatever happens in El Nino, something similar happens even here, right?
Oh.
For some reason, the wind dies down. Because of that, the warm water rushes here and the whole thing, dissipates and so on, right? So again, completely randomly, for random reasons, you can get a situation where there is no dipole in the Indian Ocean.
Right.
Sometimes it can be worse. You can get a dipole which is reversed.
Oh, cold water on the left, which is basically the western coast of the Indian Ocean,
right?
And warm water on the right, which is the Indian coast.
So that's called a negative dipole, by the way. And in a negative dipole, that will weaken the monsoon winds. You get a weaker monsoon.
Why don't we call it Chota Bachcha, man? We should call this the Chota Bachcha phenomenon.
Yes. Now, this is what you have to remember. Okay. These two are random phenomenon, El Nino and the dipole reversing, right? So they have their own cycles. It's not even a cycle. Randomly, some year you will get a positive dipole, negative dipole, El Nino. So if there is a year when there is an El Nino, but the Indian dipole is positive, so that kind of, cancels the effect of El Nino a little bit. So positive dipole means better monsoon, El Nino means worse monsoon. So you end up with kind of okay.
Average monsoon.
If there is no El Nino and there is a positive dipole, then you get lots of rain. But you might be in a situation where there is an El Nino and a negative dipole, then you're in trouble.
Which happens to be 2026. Which
No. Right now, we have a neutral dipole. Okay. But again, dipole is something that changes rapidly, can't be predicted. What the weather people are saying is that they are expecting to be a weak positive dipole in the coming months, right? If that happens, that might save the monsoon a little bit, okay? So based on that, they are saying that we expect a monsoon of about 95% of normal, plus or minus 5%.
95% of monsoon is not bad when you think about it.
Actually, no, right? So 95% is the cutoff for below normal.
Oh.
Okay. Below 90 is deficient. That is very bad. But even below 95 is not so great.
Yeah, okay. Yeah. So that will then affect our sabzi, dal, roti, chawal prices.
Absolutely. So the effect on the farmers and the economy, right? Because what happens is that in India, say in Punjab, Haryana, Western UP, the farmers depend on irrigation. For them, it doesn't matter so much, right? Irrigation is affected only a little bit. But rest of the country, Maharashtra, Rajasthan, Telangana, all of those guys, they are primarily dependent on rivers and rain-fed farming.
Correct.
Right? Those guys can be in trouble and they have to worry about a lot of things. If monsoon gets delayed, their sowing should be delayed. If they sow too early and then monsoon doesn't come in time, then the seeds get wasted. And that, by the way, can be about 30 to 100% of their profit of the whole year if one set of seeds get wasted.
Yeah.
Okay. So, and even if they get it all correct, you might still have a situation where the rainfall is not enough. So the plants, the whatever farms will not grow as much, so yield will be lower. Or you can have a situation where the rainfall, which is a little weak, right? You end up with dry spells in the middle. And if you get a dry spell at the wrong time, again, your yield goes down. So what you have is that overall yield is likely to go down, farming yield. Because of that, food prices are likely to go up. Because of that, overall inflation is likely to go up. Lower income for farmers means lower rural demand for all goods in India,
Yeah.
right? And government having to give support to farmers and subsidies and all that, right? So generally it means not a great year.
I mean, this is a very different kind of butterfly effect that is happening in the economy, but it is happening. It is going to happen in the economy. Now, the entire concept of giving subsidies to farmers and tax breaks to them kind of makes sense when you put it in this perspective. India being an agrarian country, even more so, it makes sense. But man, I was going to ask you, why can't the weather department predict all of this happening? And then I realized, well, you don't know when a butterfly is going to flap its wings.
Exactly.
Right?
I mean, in general, weather prediction is hard. Within that, tropical weather prediction, which is for countries which have monsoon, is even harder than it is for other countries. And then within that, predicting whether the dipole is going to shift and whether El Nino is going to show up this year or not is just close to impossible, right?
Incidentally, why is it called El Nino?
So the first time they noticed this was fishermen in Peru, Ecuador, etc., right? They used to get like nice cold water and lots of fish. And then suddenly some years they realized that there is like a warm water coming here, and because of that we are not getting fish, right? So they called it the child of Christmas, because this starts around the summer of the southern hemisphere. So around December they first noticed this child of Christmas, El Nino de Navidad, shortened to El Nino, the child.
So El Nino is actually the child of Christmas, El Nino de Navidad. All right. I didn't come here expecting to get a geography lesson and understand it. But once again,
I'll give you one more lesson, right? Because of this, the amount of water in our dams will be low, and next summer it will be even less, which means we are likely to get water cuts next year. So learn to use less water.
Yeah, use less water as much as possible. And we are actually having water cuts right now. Hopefully by the time you're watching this, that problem will have kind of reduced a little bit. But to reduce it, you will have to do your part. We will have to do our part. One part we did was by explaining why the water cuts are happening right now.
Also,
Hopefully,
I mean, the more futureiq you watch, the less water you will consume. So just sit in front of the computer and watch futureiq all the time.
Do that. Watch more episodes. We have another interesting episode on the geography of this exact area that he's speaking about and how that contributed to India's population. Yeah, go check that out. Shrikant, Naveen, futureiq.